welcome everybody. We're going to be having a discussion about service-oriented architecture. We're going to be talking for roughly 40 to 45 minutes, then we're going to be turning this over to about 15 minutes of Q&A. So, moving on, in terms of what SOA is, we're going to start with what the common practice when building enterprise systems is like. So this picture that you're seeing in front of you, the classic layered architecture with UI business logic, data access logic, and a database, is something that has been drilled into us by Microsoft and the various other vendors and best practices group for quite some time. Now, with the rise of services and service-oriented architecture in general, the accepted thinking was that services go somewhere right about here, between the UI and the business logic. And one of the reasons that they went in there, because it just kind of made sense to slide in another layer somewhere, and there it was. Then people started working on doing this kind of services in the classical architecture, the layered architecture, and, well, things didn't work out as well as the huge, big, touted SOA benefits that it's going to introduce loose coupling and IT business alignment and all sorts of great and wonderful things that SOA was supposed to bring us. But when we kind of look at where we are today as compared to where we were before, it doesn't look like we got a great deal out of this services story, or at least not where they put it. So, looking at this, saying, well, what's next? Let's actually go back to what service orientation was supposed to be about in the first place. So, for those of you who have been at Microsoft conferences, you've probably heard these tenets a large number of times. I'm going to go through them fairly quickly so that we know where we are with respect to the accepted practice, and then look at a different style of dealing with services. So these tenets, these four tenets, were supposed to tell us how to build a service-oriented architecture. It said your services should be autonomous, and you should be sharing contract and schema, not class or type, and the boundaries will be explicit, and the compatibility would be based on policy. And I remember sitting in these conferences, I'm sure a lot of you had that same sort of feeling, looking at this stuff, nodding your head, and wondering, oh, is that all there is to it? What does autonomous really mean? What does an explicit boundary look like? Sharing contract and schema, if that's just XML and XSD, well, we were doing that with web services before this whole service orientation thing became the big deal. And compatibility, well, that's one that nobody ever really managed to explain in a very good way. And we were kind of left with this feeling, or at least I was, that something's missing here. This is maybe a description of some end state, but it's not very practical in terms of, well, how do I go about building a service-oriented system? So I've got this problem domain. How do I actually analyze it and take it forward in order to build a solution? And over the years, as I've been doing this SOA thing for a while, looking at these tenets, it kind of reminds me of the way I started to learn to play golf. And when I started learning how to play golf, I did just about the stupidest thing in the world. I just watched footage of Tiger Woods. Now, if that sounds stupid to you, well, it sure sounds stupid to me now in retrospect, but I figured, hey, let's look at the expert. Let's look how Tiger Woods plays golf, and then I'll just do what he does, and, well, my golf would get better. Turns out it doesn't work out that way very much. Just by looking at the end result, you don't learn very much. One of the reasons is because you don't know what to look at. You don't know enough to pay attention to the important points. And these tenets of service orientation are kind of like footage of Tiger Woods. You look at them and say, wow, if only I could do that. But there's no clear practical way of actually going and doing that and getting the benefits. So you think you're doing what the picture says, but your results aren't Tiger Woods. They're Udi swinging a lump of metal at a little ball and missing. So, looking at service orientation, I'm going to take this a few steps back and start with what we actually do know. Something that almost every programmer understands at a basic level. I'm guessing all of you on the call have a very good feeling for what coupling is. The whole issue of how many dependencies there are between things. So when we look at layers, when we look at the code in those layers, we see that there is a certain amount of coupling between the UI towards the business logic towards your data access logic, and all that towards the structure of your tables in the database. So there is inherent coupling between your UI and your business logic. It kind of makes sense because, hey, well, you know, the UI's got to get data from somewhere, and it's got to use something to update that data. There is going to be coupling there, no matter what. No matter how many layers of abstraction you put between your UI and your business logic, there will be coupling there. But when we take a deeper look beyond the layers and say, well, let's not just look at a layers level, let's actually look at the code itself and look what in the UI is coupled to what in the business logic and so on, we'll see a slightly different picture of coupling emerge. So if we look at a classical enterprise app, where we've got kind of the tabs on the top for standard ERP application, and we say we have a sales module, and we have a pricing module, and we have a CRM module, and we look at the code of this app, what we tend to see in the code itself in terms of coupling is that the sales UI piece is coupled absolutely to the sales business logic piece, which is coupled to the sales DAL piece, which is coupled to the sales data in the database. And the same is true for our pricing, and the same is true for our CRM. But what we also see, or rather we notice that does not actually exist, is that there isn't very much coupling at all between the sales UI and the pricing UI and the CRM UI, or the sales business logic, the pricing business logic, and the CRM business logic. We also see that the UI of sales isn't coupled to the business logic of CRM. So if we go back and think about our tenets of service orientation, and these tenets are telling us services should be autonomous. Well, what does autonomy actually mean? Well, if one service had a lot of dependencies on another service, it would be hard to say that that service was autonomous. So, vice versa, if a service is something that has a minimal number of dependencies, we should look for candidates in our system that don't have very many dependencies on each other. And it turns out that these vertical slices don't have very many dependencies on each other. So from that perspective, if we say services are things which are loosely coupled, and we see these vertical slices in our system which already are loosely coupled one from the other, maybe those things are good candidates for services. Not services in the web service sense or WCF service sense, but in that abstract service orientation kind of sense of autonomous things. So if we say that these things are our services, what we can see is that on this vertical axis within a service, we have type coupling. UI talks to BL, talks to DAL, talks to database. However, on the horizontal axis, it looks like we have much looser coupling. The way that we build systems today is very much based around the idea of these layers being the important part of your architecture, the primary decomposition of a system. But it could be different. What if we had one solution that had the sales service in it with its UI, BL, DAL, and database, and another solution, Visual Studio solution, with its own UI, BL, DAL, and database. And between these two solutions, between these two services, they didn't have any references on each other. In other words, layers and services are very different from each other. These large autonomous services span multiple layers. They can have a UI, they can have a business logic, they can have their own database. And that's actually where the loose coupling comes from. Not by introducing web services or some other technology, whatever it is, into an inherently tightly coupled pipeline. Now, I'm not saying that web services are bad. Web services are a fine technology. Sorry, just a second. Here's some noise in the background. So make sure to mute yourself, especially if you are a new attendee. Please mute yourself. Moving right along. The one area, when we look at this kind of picture here, that seems to screw up the whole loosely coupled story is database. Now, one of the problems with the database, I'm not sure if it's a problem, but one of the issues with it is that we're used to having a single database where we put all our tables and they have primary key, foreign key relationships between them. This referential integrity ties the shoelaces of our autonomous services and prevents them from actually being as autonomous as they could. Now, the thing is, we've gotten so used to having everything in one database and having everything be always consistent, we never really thought about, do we need it? And this style of SOA, where we look at services not at all from the technical perspective, but from the business perspective, as being everything to do with sales and everything to do with pricing and everything to do with customer care and customer relationship management. Who said from a business perspective that each one of these domains needs to be 100% always up to the millisecond consistent with all the others? Because that's what the database enforces for us when we put everything in a single database with foreign key constraints. But if every service was autonomous inherently from a business perspective, and every service had its own database, had its own tables, then, well, we wouldn't have referential integrity between those different databases, which wouldn't reintroduce the coupling between our services. One thing that we would need to be a lot more conscientious of is how does data get shared? How does data move between services? If there isn't some magical shared database where you can just go and get whatever you want, if you only have access to your database, to your own tables, and anything that belongs to another service you don't have access to, where's it going to come from? In other words, if we do have this horizontal loose coupling, we're still going to need to move some data around. We're going to talk about that towards the second half of this presentation. So one thing I want you to start thinking about is, I don't need to put everything in one database. If I have autonomous services that are these vertical slices, I should be thinking of each service as if it had its own database, as if it had entire control over its own tables, which means no foreign key constraints between tables belonging to different autonomous services. Think about it as if it was actually a separate database. By doing that, by enforcing that autonomy all the way down, that's what's going to start guiding your thinking in terms of sharing the right amount of data the right way between these logical services. The other side of things that throws people off all the time about SOA is the UI piece. So while people are used to thinking, well, yeah, okay, I can see how business logic of sales and business logic of CRM are really independent of each other, sometimes in the UI, I have to show stuff together. It's not independent. It's not autonomous in the UI. It's all together. So while in the database, okay, well, yeah, I'll give each one its own database and still need to solve that data sharing problem that we're going to talk about in just a few minutes. Let's talk a little bit about how we split apart the UI. In other words, if we can disconnect our autonomous services from the bottom at the database level, we still have to disconnect them at the top on the UI level for us to actually achieve autonomy. So let's look at a couple of ways of doing that. So if we do view each of these UIs as autonomous, belonging to autonomous service, we still need a way to stitch them together. And we're going to be talking through really quickly 2 examples of how to do a composite UI. Now, eBay and Amazon have a fairly crazy amount of data on a single view at a time. What I'm going to be describing here is how that single view actually becomes a composite view and how that enables us to maintain autonomy at the UI level, at the topmost level of our services. So let's talk, first of all, eBay, how they do it on the browser side. So when we look at the eBay homepage, we can see this picture. And we have the daily deal to the left. We have our categories underneath that. We have our welcome area that deals with all the user management, and we have hot brands. Logically, from a business logic perspective, from a business perspective, we can understand that having a category logical service, or let's call it a product catalog that deals with what are the categories, which products belong to which categories are topmost. That sounds like a good logical autonomous service in its own right, entirely separate from the daily deal autonomous service. And both of those are separate from our user management, from our welcome autonomous service, and from our hot brands autonomous service. So the thing is that even though they're all shown on one page, when we actually log into eBay, if you take the millisecond or so that things start flashing on your screen to slow down your thoughts and think, what am I actually looking at? You can see that, well, an interesting number of things are happening. That on top of this browser, we actually have some generic layout piece that things start popping into. So we have a certain part or a certain service that deals with just what's the layout, what are the things that are shown on the home page, and that can be as simple as just having a CSS and a JavaScript file. It says, okay, I have 4 main sections, and this is where they come from. And every one of those is, in essence, its own URI. So the section that is the categories is just a link in that layout. And then the browser, the JavaScript that is run, layout.js, which is run by the browser, goes and says, oh, okay, I've got a link here. And it's telling me, go to categories. That's generic code. That's generic UI composition code that makes a call to the category service and says, hey, you know, I need this URI / categories. What have you got for me? And then the category service says, oh, right, yeah, you're the home page. Here's the categories for you. And the same thing for the daily deal. The same thing for our welcome screen. Same thing for our hot brands. In other words, the UI that composes this stuff doesn't actually depend on the services. All it really has is a bunch of links. Each one of those services, the UI of the category service, doesn't know anything about this UI that's calling into it, and it doesn't care. All it says, hey, you asked for categories / categories, here you go. And it provides the relevant HTML, provides a div that says, okay, div, title, shop your favorite categories, div element, antiques, div element, art, yada, yada, yada. It spits out a bunch of HTML. Now, the thing is that HTML is a fragment. It's not a whole page. So each service here, its UI serves a fragment. It says, well, you know, this is my piece, and the daily deal shows its piece, and the welcome part shows its own piece. And every one of our autonomous services has its own UI. There is no one generic UI calling 10 web services, getting the data, and building up the screen. Each UI piece is independent of the others. Each UI piece talks in a tightly coupled way with its back end, with its business logic and data access and web services. However, there is no one logical piece of code that is dependent on these services. The layout of the home page is really just a collection of links. Now, this works great for browser-side composition, but for companies like Amazon, where search engine optimization is important, where the content itself can't be brought in through JavaScript, they need something else. So Amazon does server-side composition. So if we look at an Amazon product page and we look at all the stuff that's in there, say, well, there is product catalog stuff. In other words, what's the name of the book? What's the image of the book? Is it hardcover, not hardcover, that kind of stuff, which is one service. Then we have the price of the book, which belongs to another service. Then we have the shopping cart, which belongs to another service. Then we have the editorial, which belongs to another service. And what we'd like to do is to maintain those autonomous services, to keep them separate from each other, but still have a way to build a single response that is search engine friendly. So the way that we do this is just regular HTTP processing pipeline. Amazon doesn't work with ASP.NET, but if we were working with ASP.NET because we're .NET developers, this is virtual alt.NET, so the .NET is still there. Each one of our services has its own module. And as the request goes through, it goes through each module at a time. So similar to the eBay example, we have our generic layout section that provides its own div, says, okay, this is what I put at the top, and defines what the CSS is for everything else. So it provides the CSS files, it provides the generic divs, it also defines the CSS parts that says, you know, what does or where does the content go? So that when our product catalog spits out its HTML, says, okay, I've got a div, and one of my divs is the catalog.name, there's a CSS element that says catalog.name is positioned here with this font, and catalog.hardcover is positioned here, and catalog.image is positioned here. In other words, our first layout ASP.NET module spits out all the CSS definitions, which are used by all the autonomous services that come after it. So when price gets the request, okay, it has its own ASP.NET module, and says, okay, someone has asked for a product page. I get to look at the URL and say, oh, okay, that's the product ID. Go to my pricing database, get the price, and spit out a div containing that price. And the same thing in terms of inventory. Is the product in stock or not? When will it ship? So in this HTTP processing pipeline style, every one of the autonomous services sees the request for the specific product page with the specific product on it. Can go to its backend systems, each one to its own database. Product catalog goes to its own database, looks up the product with its ID. Same thing with price, same thing with inventory. All of them seeing the same URI, each one of them getting to spit out its own HTML. And because we had that generic layout piece at the beginning, they got to define, well, where is it? Where do all these things get located on the page? The layout just happens the right way, without actually having a single GUI piece that knows about all services. That was very much the fallacy in terms of how we try to do SOA with web services. Our GUI, complicated GUI like the one that we're seeing, would have to call a very large number of services / web services in order to get all this data and show it. The problem wasn't that created a large amount of coupling. One thing that was tied to in other services, which created versioning problems, which created all sorts of technical issues that later on we were kind of left scratching our head. Was this the point of SOA? Over in this style, whether it's browser-side, eBay style, or server-side, Amazon style, or if we're talking about Smart Client, where we have things like the Cab or Prism, which also enable us to do a composite UI in a nice way, what we can see is that by having these tools to, in the same view, in the same form, in the same thing that the user is looking at, so that the GUI of each service can put its stuff in there, then what we've done is we've disconnected the thing that used to tie all our services at the top. And after having done that, said, okay, so we have independent service that deals with sales, that has its own GUI, has its own database, has its own business logic. In essence, we could have one team build that entire, well, it's an application in its own right, practically. That's what autonomy buys us. Teams working in parallel on different services. And if you've heard about Amazon talking, though they don't talk very much about their SOA methodology, they do talk about the fact that each service has its own team. They talk about 2 pizza teams. So a team has to be such that you can feed it with 2 pizzas, which means the services have to be fairly tight. So it's a fairly small team. And when they talk about a single page in Amazon may end up involving 15, 20 to 30 services, well, we can understand why, because of this composition model. Yet each service maintains full autonomy. By having this generic UI piece that does the layout and stitches them all together, both Amazon and eBay are able to maintain their autonomy. They've also taken care of it at the database level as well. So if we look at how do we go about when building a service-oriented architecture, how can we go about disconnecting these things? Those are 2 things to keep in mind. Composition at the UI level, no foreign keys, nothing tying them together at the database level, and then full autonomy. We're left with the one final question of, well, if these things are so darn autonomous, how do they share data? Because let's face it, they have to. So let's take a look at how they can do that now that we've separated them all so very, very much. So the question becomes, how do we tie the data from all of these services to each other? If they can't access each other's database, we still need some way to synchronize between them when stuff happens. And publish subscribe as a messaging pattern is a way to do that. Not so much from a technical perspective. This isn't UDP multicast that makes it important. It's not the technical aspect of how the messages move around on the network that's interesting. What's the big thing here is logically, from a business perspective, how does the data flow? When does the data flow in order to maintain this autonomy? So let's take a look at the example that we had before and say, well, let's step through the kind of loosely coupled synchronization that would happen between these services that are, so far, fairly autonomous. So one of the things that we want to know about in sales is what kind of discount should we be giving a customer? Now, from the CRM system's perspective, they don't deal with discounts, they deal with a customer status. Are you a silver customer? Are you a gold customer? Are you a platinum customer? With all that entails. But they deal with the status. That's what they manage. The guys from sales are interested in which customer is which status, because that'll tell us what kind of discount we have to give that customer. So anytime that something happens in the world of CRM with respect to customer status, sales is interested. So we want to subscribe. We want to say, tell us when someone becomes a platinum customer. That's interesting to us. And CRM periodically publishes these customer status updates. Now, the CRM system can do it right away. So the millisecond that the customer status changes, we can publish an event. Or CRM systems perspective, they say, well, yeah, we could do that, but we'd have to buy all these machines and have to have it highly available. Let's just do a nightly batch, which is fine as well. It's not so much how the message is propagated on the network, whether this is using MSMQ or using FTP, is besides the point at this level. But logically, we're talking about the fact that CRM lets the world know about business events that are of interest. And other parties can express their interest in those business events and take what information they need from those events and store it locally. So the guys from sales say, oh, okay, you need to have become a platinum customer? Well, okay, let's write that in our database because we might need it later. Well, let's continue on. Well, sales isn't just interested in what kind of discount. They're also interested in knowing, well, how much products cost. And that comes from pricing. That's something that the guys from pricing deal with. So every once in a while, whether it's once a week or once a day or whatever, the guys from pricing issue a new price list. And the guys from sales say, whenever a product's price changes, let us know. We need to be working off the correct price list. And the guys in the marketing department once a week publish a new product price list, and then they actually publish once a day or once an hour hot deals. Products that have had their prices drastically reduced. And the guys from sales take that information and say, okay, well, we need to know that. We need to know which product costs how much. And once we have all this information, when we finally come face-to-face with the customer, and the customer comes to us and says, yeah, hi, I'd like to buy some products. You say, oh, okay. Hello there, whoever you are. Give us your customer ID. We'll go look in our database, not the CRM database. We don't make a web service call to the CRM system. We look in our own service, find what discount that person needs to get, look at the products, the product IDs that are in that order, and look for the pricing information in our own database. And once we have all that information, say, oh, looks like a good order. Buying products that exist, that we have the prices for. We know who our customer is. We know what discount to give them. We can accept that order. And that event is an interesting event in its own right that we publish out and say, hey, we've accepted an order from so and so for these products, for this amount of money. And at that point, the guys from CRM say, oh, okay, so John Smith bought some more products. Well, then that brings him over the $1,000 per month threshold, so he's now a silver customer. So we're going to publish now John Smith is a silver customer. Customer status updated. The guys from pricing are going to say, wow, these bicycles are really selling. Let's jack up the price. And then they'll spit out their own events. In other words, we can look at the business processes going on between these services and model them as a series of business events that feed into each other. After we have an idea of what the business events are, then we can look at actually employing a publish-subscribe infrastructure in order to move these events around, in order to express who is subscribed to which event. Now, all of this stuff, all of this loose coupling that we're introducing opens up things that we may not have thought about before. In other words, what if pricing went down and didn't publish a new price list? What do we do in sales? Do we work off the old price list forever? In other words, once we have given up 100% always-on consistency by actually calling via a web service or directly the pricing database, and the database is unavailable, then we get into an interesting business question that says, how long can we work off of the price list without getting another update? That's a business question. That's not a technical question. This is not a technical, high availability question. Technically, sales is entirely autonomous, and they can work off the old price list forever. From a business perspective, the question is, should we? And once someone from the business says yes or no, or, well, you know what, that's an interesting question. I've never thought about that. Then they get back to us later and say, well, these price lists are valid for up to a week. So if the products that someone is ordering, the price that you have for them is more than a week old, say, sorry, I can't accept that order. Those products are currently being reviewed. But this is what the business needs to tell us. They have to say, we're willing to accept the fact that you're going to reject an order because you don't have up-to-date pricing information. And then, well, someone's going to be asking, well, why the hell didn't the guys from pricing publish their weekly price list? In other words, this feeds back into service level agreements, not technical 3 nines, 4 nines, that kind of stuff, SLAs, but from a business perspective. The business SLA of the pricing department is to put out a new price list at least once a week. He can do it more often if it likes, but that's the minimum it has to do. Whether it's machines or 3 nines, 4 nines, or 1 9 is besides the point, as long as it can maintain that business SLA. Because that's what makes all this loosely coupled synchronization work, from a business perspective. Once we have that input, we can say, oh, okay, so if pricing needs to do this and is pushing this many price lists, then we actually need this many machines in order to comply with that business SLA. And that's where this service-oriented architecture style starts bringing in IT business alignment. Because all the technical decisions that we make in terms of when do we publish these events, what should I do if I don't get an event back, what kind of technical SLA do I need, are my web services fast enough, all happen within a business context. And we really only find out about that business context by taking away automatic consistency, by asking ourselves these questions. Well, what if that event didn't go across in time? In fact, that word, time, starts to have meaning. We start to address it explicitly in our system. We start to write business logic for it in our sales service. A product doesn't just have a price. A product has a price that is valid for a week. In other words, we start to introduce not only what is the data, but what's it good for how long? By taking away the consistency, we ask the business people the right questions, not in IT speak. So, Is my web service good? Is 3 nines of availability good for you? If I can do 4 nines, but that'll cost you. Business doesn't know how to answer those questions. But coming to business and saying, well, look, from our sales system, we've designed the system in such a way that even if the CRM servers and the pricing servers are down, we can still accept orders. So you don't need to worry about that anymore. We don't have to have everything on all the time, invest a fortune in infrastructure everywhere just for things to work. We're IT, we handle that. We handle the technical autonomy piece. HubSub gave us that. The caching gave us that. But now we have some business questions. If pricing is down for a day, a week, a month, and we don't receive an event, or if they're up and they just didn't publish the event, it's the same thing from our perspective of sales. What should we do? Should we reject orders, or should we tentatively accept them? In other words, we start looking at how we modify our business logic, introduce additional states to represent, well, it looks like it's valid, but I'll have to get back to you on final validity. So from a UI perspective, when the user clicks the button and says submit, yeah, I'd like to submit my order, we don't actually come back to them and say, oh yeah, it'll be shipped tomorrow. We say, look, we've received your order, we'll get back to you via email with its status. Say, oh, look, it's been tentatively accepted. It's pending new pricing information. If the new price is less than what we showed you on the website, we'll just give you that and we'll move right along with your order. On the other hand, if the new price is higher than the price that we showed you when you placed your order, maybe we'll send you an email saying, would you like to modify your order? Or maybe if you're a gold customer or a platinum customer and the difference in price is less than 5% of the value of the order, we'll swallow the loss and we'll just go ahead with it. In other words, it's additional business rules that tell us what to do, that put the business context of what does it actually mean for something to be valid, to be consistent. A lot of people have been talking about eventual consistency for a while now. Well, what does that mean? Technically, it means that no foreign keys. Things aren't necessarily consistent. But that needs to be added to by the business, and it's through these questions that say, for how long can this be out of sync? What should we do? I mean, we can write code to do anything. We can accept the order, we can reject the order, we can tentatively accept the order, we can do calculations based on the customer status. Business, tell us how to make this consistent for you. Tell us what valid means to you, and we'll represent that in our system. Eventual consistency and resolving it is not a technical affair. It's for us technical people to come to the business and have them tell us what does consistent mean in this technically, eventually consistent world. What does valid mean? And often that means additional statuses for our entities. So as we look through this whole SOA story, wrap it up and say, well, what have we done? What was the point of all of this? We look back at, well, where were we when we started out this whole story? Services are autonomous. Well, they are if you do them like this. It's not easy. It's not immediate. It doesn't happen by virtue of using web services, WCF, N-Service Bus, Mass Transit, PubSub. It doesn't just happen that services are autonomous. There's a fair amount of technical and business work to do in order to separate things the right way. To look at the fact that, no, the UIs, there is no one UI. There is the UI of service A and there's the UI of service B. Things aren't shared. We have some composition framework, but there's no real sharing going on there. Databases are independent of each other. When we talk about that, say, well, that's an explicit boundary. Nothing is shared. Services don't actually call each other. Definitely not in a synchronous blocking way. That's a boundary that you can look at, that you can draw, that we saw in here, that cuts all the way through. UI, DL, DAL, database, all the way through. It's its own application for all intents and purposes. Inside that service boundary, you will find type coupling. There's nothing you can do about it, because, hey, type coupling is what makes code work. They're your boundaries. They're not technical boundaries so much as business boundaries, which is why actually looking at them from the UI perspective is often very effective, because we often see that separation at the top level in these enterprise-style apps. We don't see very much mashing up like we do in their web counterparts like Amazon and eBay. Once we have that and say, well, what exactly are we sharing? Well, we're sharing contract and schema technically, but that's not really what's interesting. The thing that's shared between our services are business events. In other words, what we're publishing and subscribing, they're not just messages from a technical perspective. They represent events that have significant business meaning, which is why they move between these highly logical business services. Don't expect to see request response in there. Every service is its own world and said, I did this, just letting you know, but I'm going on about my business. So when you look at it, say, share contract and schema, well, yeah, but if what you're sharing conceptually is a business event, you've done most of the work. If for performance reasons you decide to have an in-memory binary serialization transport hooking these two up, that's an implementation detail. We need to separate out between logically what is shared, the business event, and technically, how do we move that event from one place to another? That's where non-functional requirements like performance and latency and throughput and security start coming into play. But all of those are implementation aspects of how we move these business events around. Keep in mind that when looking at the previous picture, absolutely, you can have multiple services or multiple parts of logical services installed on the same machine. In the Amazon story, every one of those ASP.NET modules is on our web farm. So the thinking that services map fairly cleanly to machines, actually, there's no connection at all. We can take code from multiple services and deploy them to the same machine, to the same process even. Or we can have them running on separate machines. That's a deployment issue. Don't look for a high correlation between autonomous business services and their boundaries to physical machine installation deployment boundaries. Which is why if we have code from two logical business services, two pieces of code that are on the same machine and are running in the same process, and one is publishing a business event, using an in-memory transport to get that to the other service is perfectly all right. It's deployment detail. And you should expect to see that different services in different places use different technologies to move the events around. From the highest latency, slowest thing in the world of getting a bunch of stuff into a business intelligence data warehouse that can be done FTP in a nightly batch, to the highest level of, the way that Amazon does shopping carts and pricing. Those two things talk to each other really, really tightly. You need a really high performance connection between them. They're using a different technology. But in both cases, what we're moving are business events. So when thinking about the technology underneath every one of your services, do expect to see that some places you're going to be using one technology, other places you're going to be using other technology, some places MSQ, some places FTP, other places whatever. All of that is implementation, deployment issues under the top-level autonomous breakdown. This is what we're talking about here. This is how services share information. So, wrapping up the hour, gone through what services are, what business services are, what their boundary means, how UIs are broken down. That in essence, a UI is a part of a service. A web service, a logical business service. A database is a part of a logical business service. Services don't share. Why? They don't share a database. Hey, one service could even be using an object database, another service could be using an XML database, third one could be using a relational database. Each service kind of gets to decide what the best implementation for its needs is. That's the design time aspects of autonomy. Each team gets to decide how to build their own service, the internal part. So, business services, explicit boundaries. UIs are inside services, business logic, web services, databases, and the way that these things keep each other in sync through business events. So, at this point in time, I'd like to thank you all very much for your time and for your attention. Nobody, if anybody at all, dropped off. And now we're going to be turning it over to Q&A. So, Colin, please feel free to start firing questions away whenever you're ready.
Sure thing. Much appreciated. This one's from John, and it's, is SOA a good match for a small dev team?
Okay, is SOA a good match for a small development team? That's somewhat a loaded question because it's more an issue of, well, what are you building? If you're building a compiler or a device driver, then maybe not. Maybe all you have is a single business domain. So it's not so much the size of the development team, but the nature of the thing that it is that you're building. Are there boundaries in there? Does the business lend itself to be broken up in this manner that lets us know whether there's value in the approach? A small development team, the benefit that they'll gain from this is a more loosely coupled code base that will be more maintainable over time. So if SOA is suitable for the problem domain, then yes, it will be suitable for a development team of any size. Next question.
All right. The second question is also from John, and he asks, any observations on how many devs would typically work on a single service?
okay, how many developers work on a single service? Once we define a service, a logical business autonomous service, as this entire unit, in other words, it will likely have a UI in many cases. It will likely have a database of sorts in its back end. It will likely have to deal with security and performance, likely have a fair set of business logic. Then it's really how many people does it take to build the service? The other side of it that often does not get asked is, well, the service also includes the testing of a service, the deploying of a service, the keeping the service running, backing it up, deploying patches, fixing bugs. In other words, it is a full life cycle thing. So we should look at it from that perspective. In other words, this is a long-lived application that we need to be dealing with, building it the first time and supporting it afterwards. So we'll tend to see some kind of manager, a certain number of developers that may be anywhere from 5 to 10, depending on how big it is we're building. Probably similar numbers of testers, depending on where we are in the life cycle, and some operations team in order to look at keeping it running. Now, whether that's on the cloud or not, it's not really changed. It just changes the way that the operations team does their work. But in this regard, I'd say that Amazon's rule of 2 pizza teams, where if you can feed your team with roughly 2 pizzas, then that should be roughly what you're looking at. Certain, around 5 developers, 3 to 5 testers, 1 or 2 operations people, maybe a manager. That's rough, the size. The important thing to understand as a corollary to that is that the service team is kind of like the agile, multidisciplinary team. In other words, that it includes the business analysts and the testers and the people that install it and the people that run it. In other words, it's everybody involved with actually getting this service out the door and keeping it running. So it's not, the question is not how many developers are there, but to understand that this is a multitude of skills that we need on this team in order for the service to work. And in that sense, SOA starts breaking down a number of organizational boundaries that we may have gotten used to over the years, that BAs are in that team, and the developers are in this team, and the testers are in that team, and the operations people, they live somewhere else entirely, and the DBAs live over here. Maybe that's not the greatest breakdown in the world. Maybe we need to service-orient our organization as well, and look at structuring our teams along the lines of these logical services that we've identified. But that's an organizational change story. That's often kind of consulting work that I get into with my larger clients, that in order to really reap the benefits of an SOA effort, we need to start looking at how the organization is structured, as well as how the software system are structured. I'll just end that question with an interesting historical anecdote. In 1967, a fellow by the name of Conway coins Conway's law with respect to software architecture, that said that the structure of a piece of software reflects the structure of the organization that built it. And because the rule or the law was coined in 67, the example he gave was a compiler. He said, for instance, if you have 4 teams working on building a compiler, you will have a four-pass compiler. Corollary of that is that if we want to substantially change the structure of the software that we're building, that we need to look at substantially changing the organizational structure, which is building those services. So in that sense, it's not so much a question of how many developers build a service, but how many people across the organization will be with the service for a while. And we actually should look at it in that sense. For those of you that are working in ISVs, companies that build products that they take a while to build, and then we want this product to have a full life, we're very careful about looking at knowledge management in the team that's building the product. So if you want to think about services similar to products in that sense, from an organizational perspective, that's not very far off. Just coming back to the original question, how many developers and testers and operations people and business analysts and all that do you need? Kind of depends on the service that you're building, but you probably will need some of all of those disciplines in a team. Next question.
So this question is from Mark, and I'm just going to add a bit onto it. How big should a service be to justify being autonomous? And I wanted to add, how do you go about defining these business meaningful services and their boundaries? Do you use sort of capability modeling or another approach?
Okay, so what was the first part of the question? How big?
Exactly. How big would a service need to be to justify being autonomous?
Well, it's a question of how do you define bigness? Is it lines of code? Is it number of machines? Is it number of screens? It's kind of difficult to say what technical factors that we have for measuring size make for an autonomous service. In other words, the size is not what makes it autonomous. We've all seen large monolithic balls of mud that aren't anywhere near loosely coupled in any respect. So size is not an indicator for whether this is a service or not. When looking at autonomy, what we look at primarily is how much does this service share with other services in both directions. In other words, what does it consume from other services, and what does it share to other services that they use on their end. So the boundary, or let's call it the ideal boundary, that we've achieved almost fleet autonomy is where besides IDs, nothing is shared. So that should be your baseline. If I can design my system in such a way that only IDs are shared, and that everything, and those IDs are moved around in these events, that's often a good clue that what you've built is autonomous. Look at adding to that baseline sparingly. So in terms of the example that we saw before, what sales shares with other people is primarily the order ID and the product IDs that it got before, and on top of that, quantities. In other words, how much of these products are in the order. Now, when I don't have a great deal of time here, but often when you think about breaking down the UI, for instance, if you look at Amazon's checkout process, and I'm pretty sure that all of us technical people have been through that checkout process a number of times when buying books, is that we see that there is a screen for shipping information, and that screen, well, it belongs to the shipping service. And then there's a screen for billing information, and well, that screen belongs to the billing service. In other words, each service because it has its own chance to interact with the user and get the information that it needs to do what it needs to do, often because of that, because of the fact that it has its own UI, that it's not dependent on other services collecting the information for it and then sending it across. So to the second, or to the first part of the question that talks about size, size often is a very poor indicator when looked at by technical people, because there's often a bunch of stuff that we don't see. In other words, a service may be very large because, well, very little is automated. In other words, a lot of stuff is done by people. And the IT systems that are part of that service, well, they don't do very much. In this picture that we're looking at here, there's nothing that says that everything in the box is computerized. There may be people in there that are publishing events to each other using email. That's fine. In other words, when looking at these services, at these business services, don't just look at the IT parts of it. And as a result of that, when looking at, well, how big is it, it's often not just an IT question. So it includes how many people are involved in processes that fall under that business services area. So in that regard, it's very difficult and often misleading to look at technical size as an indicator to whether what we have here is a service or not. Often it's a lot more in understanding what the business does in that area, also outside of the IT systems, that reflects true size, and in terms of what gets shared and how, again, looking for that minimal level. So the second part of the question of whether we do capabilities mapping and how much value it's in there. It's a value, depending on what it is that you're modeling and how much of the business you're looking at analyzing. It can be a useful tool in generating information. However, it does need to be, or you do need to look at that guideline of beyond IDs, share nothing, in order to direct your capabilities mapping effort to starting to ask questions like, well, what if pricing doesn't put out a new price list? It's often through those types of questions that take the technical property of eventual consistency and providing them business meaning on top of the business capabilities that we've identified, that the nature of the boundary becomes clearer. Because up until that point, we're not exactly sure what should happen or whether there's a boundary there at all. If the business comes back to us with these questions as, no, I don't think you understand, that has to be consistent all the time because, well, that's the business that we're in. Then it means we've introduced technical autonomy where there's no business autonomy. So it's by overlaying those technical properties of eventual consistency with the things that we've noticed in our business capabilities mapping and start having discussions around the business meaning of that, that we adjust the boundaries that we identified the first time through the capabilities modeling. It really is, over time, it's really just experience to have a nose for something's wrong here. It doesn't sound right. It sounds like I'm missing something. And drilling in there in order to find out whether you've got the boundary right or not. So it's not something that's very clear-cut, like a lot of things in architecture. I know a good one when I see it, but it's kind of hard to teach the right way to build one for any system that exists. It's the same thing that we got here. But having that that technical feedback mechanism or that rule that you can apply on a proposed solution, saying, am I sharing only IDs? Or how close to sharing only IDs am I? Will give me a good indication, did I get it right? So just knowing that I didn't get it right will make me go ask some more questions. After a while, I say, no, I keep coming back to the same solution. That's probably the right one. Next question, and then after that, we'll do one last one, and then we'll wrap it up.
All right. When do you choose between a synchronous or an asynchronous service call? The answer is probably it depends, but can you share some guidelines for choosing between the two?
Okay, so the question was, how do you choose between synchronous and asynchronous service calls, and under what conditions? So when describing business service interaction, where the interaction itself is a publishing of the business event, that is inherently asynchronous. But I'd like to redefine that word. It's not asynchronous as in it is fired on a separate thread, but rather it is truly one-way fire and forget. I don't care if this arrives at the destination kind of sending an event. So it's not something that you really could do synchronously, because, well, the other party might not be there and you don't care. So that's at the kind of interaction between business services. Within a business service, okay, UI on one machine, talking to business logic on another machine, we're getting into the technical domain of, well, you know, should we do sync or async? That's a different set of questions that has nothing to do with service-oriented architecture at all, okay? You could go for RPC between two machines within a single logical service, and that may be perfectly all right. But number one thing, between services, only one-way, fire and forget, business events, past tense, this is what happened, rather than I'm calling a service. As someone that is publishing, I'm not calling anybody, not asking anybody for anything. So in that sense, it's inherently asynchronous. It's inherently one-way. It's inherently non-blocking. Within a service, well, it's natural and it's perfectly all right to see some RPC within a service boundary. I think it's fun. So it's more about where do you do synchronous and where do you do asynchronous, rather than one versus the other in all places. Last question.
I'm going to try and get away with merging two questions that have been asked.
All right. Okay, last two questions. This time.
Yeah. The first is, the Power Presenter book, would you recommend it?
Okay, would I recommend it to whom? I think it's a fine book for people that do presentations, yes. One of many.
Right. And the other one is, this is from John, can you recommend a good book for a fresh .NET SOA architect?
Can I recommend a good book? Well, I can say that there's a new book coming from Manning called SOA Patterns by a good friend of mine, Arnon Rotzenbelos, yes. And he has a middle name too that it actually isn't in there. It's Walter. So it's a good book. It doesn't cover these business aspects of it. It's currently in early access, so the book hasn't been published yet. I may write a chapter or two for that book, so obviously I'm biased. There is a book out from InfoQ, written by Steve Jones from Capgemini, and Steve and I see very much eye to eye on a lot of these matters. I haven't read the entire book, but from what I have read, I can agree with all that I have read. So it's not, so there aren't very many books about this stuff. So if you do look at older books about systems engineering, and I don't have links for those, if you don't actually look very much at the technology parts of it, .NET aspects of it, but looking at it from a more pure systems engineering kind of practice, you'll find a lot of good stuff in there, especially looking at some of the old U.S. Department of Defense guidelines for building large-scale software systems, learn about use cases. A lot of this stuff relates to requirements engineering, so by finding breakdown at the requirements level often serves you in terms of maintaining that loose coupling all the way through. So there's a lot of good stuff out of there. It's just kind of dispersed all over the place. It hasn't been pulled into one place. So I'm afraid that there aren't very many books on this style of work, and people have been bugging me for a while to write such a book. I'm fairly busy, so I'm hoping Greg Young is going to step up to the task, and maybe I'll join him on his book and join Arnon on his book, and then maybe we can get 2 to 2.5 books out of it that'll cover this kind of stuff in a sufficient amount of detail. So pretty much read anything and everything that you can get your hands on that talks about this style of business events. Broaden your reading portfolio to include stuff that doesn't necessarily come from .NET or isn't necessarily new, as in written in the last year or two. And just look for these patterns when talking about systems, and you'll start to see them. It's really more about training yourself to look at the problem domain in this matter, rather than looking at the solution domain in terms of, well, yeah, how do we build this in terms of web services and .NET? To start listening for business events. And one of the ways to do that is when you're looking at the requirements, just look for the word when. Okay? Where you see the word when, start looking for a business event in and around that. Often, once you've defined or once you've found a business event, you'll see a service on one side of it, and you'll see another service or more than one service on the other side of it. Well, as a technique, I know that we've all gone through the object-oriented analysis and design, where people tell us, look for the nouns and the verbs. When doing service-oriented architecture, look for the word when. Often when you see that word when, it'll be an indicator there's a business event hiding there, or maybe hiding in there, may not. People aren't always very specific in their use of language. After you've found a bunch of business events, you'll be well along the path to getting services with good boundaries between them. An hour and a half later, roughly, I'd like to thank you all for sticking around to such a late hour, and hope you had a great learning experience and enjoyed the stuff that you saw. And my website again, dahan.com. Feel free to send me comments, and my email for any additional questions that we didn't get to. So thank you all very much, and have a great night.